All right, today we are taking a journey into some of the biggest head scratchers out there paradoxes. These are the little logical knots that make you question everything you think you know about language, the world, and even time itself. So let's jump right in. Let's just start with a classic. Think about it. If I say I'm lying, and that statement is true, well, then I must be lying, which would make the statement false. But hang on. If the statement is false, that means I'm not lying, which suddenly makes it true again. You feel that? That little loop your brain just did? That's a paradox.
So, what exactly is a paradox? Well, simply put, it's a statement that basically trips over its own logic. It's when you follow a set of perfectly reasonable rules, but you end up with a conclusion that's completely contradictory or, just impossible. They're kind of like glitches in our own thinking. So, for our first part, we're going to stick with these brain twisters. These are the paradoxes that pop up when language and logic look back at themselves, creating these maddening, inescapable loops. Let's take a look at some logic that eats itself.
Okay, picture this a small town, just one barber. And this barber has a very clear rule. He shaves everyone in town who does not shave themselves, and only those people. Seems straightforward enough, right? But it begs a very, very tricky question. Who shaves the barber? And here's where it all falls apart. Let's think it through. If the barber shaves himself, he breaks his own rule, because he's only supposed to shave people who don't shave themselves. Okay, so he doesn't shave himself. But then, according to the rule, he has to be shaved by the barber, which is him. No matter how you slice it, it's a contradiction. His own rule makes his job logically impossible. All right, let's try the same kind of self-referential trap with a character we all know. The rule for Pinocchio is simple. His nose grows if and only if he tells a lie. So, what do you think happens if he looks you dead in the eye and says, "My nose will grow now"? And boom, logic eats itself again. If his nose actually starts growing, that means he was telling the truth. But his nose is only supposed to grow when he lies, so that can't be right. Okay, what if his nose doesn't grow? Well, then his statement was false. It was a lie, and that means his nose should have grown. It is a perfect logical trap with no escape. The unstoppable force versus the immovable object. This one feels like a clash of titans, right? But it's not really about physics, it's about our words. You're creating two concepts with absolute competing definitions. I mean, the second you say a sword is truly unstoppable, the whole idea of an unbreakable shield can't exist in that same world. And vice versa, they just can't logically be in the same story. Okay, now let's move out of pure logic and into the physical world, or at least how we try to make sense of it. The ancient Greeks were masters of these kinds of puzzles, and they used them to pick apart our basic ideas about motion, space, and identity.
This brings us to a really famous one from a philosopher named Zeno. You've got Achilles, the fastest guy in all of Greece, racing a tortoise, and he even gives the tortoise a head start. I mean, we all know how this ends, right? Achilles is going to smoke that tortoise. But when Zeno breaks it down, things get weird.
So here's the problem. To catch the tortoise, Achilles first has to get to where the tortoise started. Makes sense. But in the time it takes him to do that, the tortoise has crawled a little bit farther. Okay, so now Achilles has to cover that little distance. But in that time, the tortoise has moved forward again. This keeps happening, creating this infinite series of smaller and smaller gops. Logically, it seems like he can get infinitely close, but never actually overtake it. This one is less about motion and more about identity. What makes something itself? So, imagine a legendary ship is being kept in a museum. As the years go by, the wooden planks start to rot, and one by one, they get replaced. Eventually, you get to a point where not a single original piece of wood is left. Is it still the ship of Theseus? Now, what if you took all those old original planks and built a second ship out of them? Which one is the real one? All right, so we've looked at individuals and objects. Now, let's zoom out and look at how we behave in groups. These are the kinds of paradoxes that pop up when all of us, acting rationally on our own, end up creating some really strange results for the whole group.
So here's a fun one that is statistically true for most people listening to this. It's called the friendship paradox, and it says that, on average, your friends have more friends than you do. It sounds kind of insulting, right? But it's just math. Think about it. You're way more likely to be friends with a social butterfly, someone who has tons of friends, than you are to befriend a total loner. and those super connected people pull up the average for everyone in their circle.
This paradox really shows how what's smart for one person can be disastrous for everybody. Look, for you as an individual, saving more money is almost always a good, responsible choice. But if everyone in the country starts saving and stops spending at the exact same time, demand for everything plummets, companies start laying people off, and the whole economy can grind to a halt. What's a personal virtue becomes a collective vice. And this one feels so modern. We're always told that more choice is more freedom, and more freedom is always good. But it turns out that's not always true. You've probably felt this. You're trying to pick a show to watch, and there are thousands of options, so you just end up scrolling for an hour. Studies show that when we face too many choices, we actually get anxious, we're less likely to choose anything at all, and even if we do, we're less happy with our decision. Sometimes less really is more. Okay, for our final section, we're going big. Really big. These are the paradoxes that come from the absolute cutting edge of physics, the ones that make us question the nature of time, space, and reality itself. This is the Fermi paradox, and honestly, it's a bit haunting. Just look at the numbers. There are billions of stars in our galaxy alone, and the universe has been around for over 13 billion years. The odds seem to suggest that intelligent, spacefaring life should have evolved somewhere else by now. So the simple and deeply profound question is, where is everybody? Why is it so quiet out there? Thanks to Einstein, we know that time isn't this fixed universal clock. It's relative. And one of the weird consequences is that the faster you move through space, the slower you move through time. This leads to the famous twin paradox. Say one identical twin hops on a spaceship and zips around the galaxy close to the speed of light, while the other twin stays on Earth. When the space twin comes back, they will have aged way less than their sibling. They are now physically younger, even though they were born on the same day. And last but not least, we have to go into the bizarre world of quantum mechanics with Schrödinger's cat. So imagine a cat is in a sealed box with a vial of poison that will smash if a single radioactive atom decays. Now, quantum physics says that until we actually look at that atom, it exists in a superposition. It's both decayed and not decayed at the same time, which means the cat whose fate is tied to that atom is also somehow both alive and dead until we open the box and look. So after all of that, what's the takeaway? Are these paradoxes just mistakes, flaws in our language and logic that we'll eventually figure out and fix? Or are they something more? Are they pointing to a reality that is fundamentally stranger than our brains are built to understand? Maybe, just maybe, they're not problems to be solved, but signposts showing us the very limits of what we know. And that, perhaps, is the ultimate question they leave us with.